Okay, in this demo, I'm going to give a quick walkthrough of the notebook linear algebra for deep learning. Initially, what I do is in the opening cell, it brings everything together by implementing a full neural network forward pass from scratch, and how is all defined here. In the next cell, I apply L1, L2 under Frobenius norms to a way matrix to demonstrate regularization. Uh, After that, I then this cell plots the unit ball for L1, L2 and L infinity norms side by side, as we can see. In the next cell here, I compute all the three norms of a vector using numpy line alg dot norm. And after that, then this cell computes the eigenvalues and eigenvectors of a 2 cross 2 matrix and visualizes them as a arrows on a 2D plots. After that, here I compute eigenvalues and eigenvectors numerically using numpy.linealg.ig and verify the result by checking that A times V equals lambda times V for each eigenvector. After that, this cell visualizes how three different matrices transform a unit square. One scale it, one share it, and one collapses it into a line. Next, after that, here I compute the inverse of 2 cross 2 matrix using numpy.linealg.in and verify it by checking that. After that, this cell implements a simplified version of the scale dot product attention mechanism using query and key matrices. In the next cell here, I transpose a 2 cross 3 matrix to produce a 3 cross 3 matrix using the T attribute and visualize both with heat maps. In the coming up, this cell visualizes the batch matrix multiplication that represents a neural network layer showing the input batch, way matrix bias and outside side by side as heat maps. After that, in the next cell, I demonstrate how a way matrix transforms an entire batch of 4 samples with 3 features each into a 2 output features using a simple matrix followed by a bias addition. Next is this cell visualizes a matrix multiplication of 2 cross 2 matrices step by step, showing A, B and the result C as colored heat maps with multiplication sign and equal signs between them. Next is matrix multiplication computation. I perform matrix multiplication of 2 cross 2 by at operator and manually verifying top left element by computing the dot product of the first row of A with the first column of B. Next is visualizing matrix multiplication. Here we visualize 3 cross 3 weight matrix multiplies into a single input vector to produce an output vector, drawing each dot product computation explicitly. Next, I compute the matrix vector product y equals w times x for a 3 cross 3 way matrix and a 3 element input, printing the step by step dot product for each output element. Then the next cell demonstrates element-wise matrix addition and connects it to the deep learning context of aggregating output from multiple attention heads. In the next cell, I compute the element-wise product of two vectors using the asterisk operator and distinguish it clearly from the dot product. In the next cell, I compute cosine similarity between word embeddings for words like king, queen, man, women, and apple. And these are the outputs of it. Next, here I plot vectors at different angles from 0 to 180 degrees and show how their dot product with reference vector changes. After, in the next cell, the dot product of two vectors using a numpy dot, the at operator and manual summation of element wise product, confirming all three give the same result. After that, here I multiply vector by scalar and connect it directly to gradient descent, where the learning rate scalar multiplies the gradient vector to produce the weight update. In the next cell, a Ross vector as a arrows in 2D space and shows their sum geometrically as the diagonal and parallelogram they form. After that, then I add two vectors element by element and demonstrate how the maps directly to adding a bias vector to a layers output in a neural network. Then this cell prints the denser shapes used in popular deep learning tasks like MNIST digital classification, ImageNet with ResNet, BERT text processing and video classification. Then here I plot a bar chart showing how dimensionally increases from scalar to vector to matrix to 3D tensor and draw a 3D cube to represent a rank 3 tensor. Next cell creates a 3D tensor of shape 2, 4, 3 representing a batch of two sentences each with four words and each word embedded in 3D dimension. After that, I visualize a 4 cross 3 way matrix as a heat map and show how it transforms a batch of input samples. Next, this cell creates a way matrix and multiplies it by a batch of 3 samples to produce a layer output showing the shapes at every step. In the next cell, I visualize 2D vectors as arrow from the origin and show a future vector as a bar chart. And in the next cell creates a several real deep learning vectors, a future sample from the iris dataset, a bias vector for a 3 neuron layer, and a word embedding. After that, I define scalars that appears throughout the deep learning data, loss value, and temperature for softmax. Then this is the main setup cell that imports NumPy and all the required libraries and configuration, the plot style and font sizes, and set the random seed. In the next cell implements the computation of single neuron from scratch. It takes three input futures, multiplies each by its learned ways, sum all the three products, and add a bias. In the last cell, the final cell visualizes the single neurons computation as three bar chart showing the input, the weights, and the resulting output side by side. And that's it with this demo. Thank you.